Alright, this video is over the sum and difference identities for sine and cosine. Alright, and so those are these four. Alright, so make note. These are the four identities for the sum of two angles, a plus b, and the difference, a minus b and a minus b. When we take the sine and cosine of the sum or difference of two angles, these are the four identities. Alright, so make note, we need to know these four. You got to find a way to remember. Okay, cosine of a minus b goes to cosine a cosine b plus sine a sine b. One way to kind of help you remember is to notice on the cosines that it goes cosine cosine and then plus or minus and then sine sine. Everybody see that? Whereas on the sine formulas it goes sine of the first angle times the cosine of the second angle plus or minus the cosine of the first angle times the sine of the second angle. So just find a way to remember these, because we will be using them and they will come in handy if we know them off the top of our head. There are two others for tangent. Now, these two can be derived using the formulas that we had on the previous page and then a little bit of algebra, and then you get down to these identities. I'm not going to require that you guys memorize the tangent of the sum and difference of two angles because you can always derive them if you need to. But if we need them, we'll probably just look them up and go about our merry way. All right? Okay, so these we have to know. All right, here we go. Find the exact value of the sine of 75 degrees. Now, we all know that we could plug 75 degrees into the calculator and get an approximation. Using our formulas that we had just a minute ago, we can come up with the exact value. And this is just an exercise in making sure we understand how to use those identities that we had a minute ago, the sum and difference identities. So the first thing we want to note is, well, 75 degrees. Well, we from our unit circle, we already know we've got some special angles, right? 30 degrees, 45 degrees, 60 degrees. So the question is, can we rewrite 75 degrees using a combination of those angles? Well, hopefully we all see that, yeah, we could rewrite 75 degrees as the sine of 30 degrees plus 45 degrees. Everybody agree we can do that? Then we just use the sine of the sum of two angles, right? Because you're adding these two angles. What was that formula? Well, it was the sine of the first angle times the cosine of the second angle, and then plus, because the formula is for sine, this plus or minus here was whatever the plus or minus was up there. The cosine of the first angle times the sine of the second angle. Right? So what's the sine of 30 degrees? Sine of 30 degrees is 1/2. Right? Cosine of 45 degrees is the square root of 2 over 2. Right? And then the cosine of 30 degrees is the square root of 3 over 2. And the sine of 45 degrees is the square root of 2 over 2 again. And so when you add all that up, you get the square root of 2 over 4 plus the square root of 6 over 4. So you get the square root of 2 plus the square root of 6, which does not go to the square root of 8, all over 4. That's it. That's the exact value, right? Using our identity. That's funny, Danny, but the sum and difference formulas come in handy when we have something like such. All right, so we've got the cosine of one angle, cosine of A, which is 3/5, and the sine of a different angle, in this case B, so the sine of B, in this case is 5/13. And we note that angle A is between 0 and pi over 2, so that puts angle A in quadrant 1. And then angle B is between pi over 2 and pi, so that puts angle B in quadrant 2. Everybody see that? Very important that we know what quadrant our angle is in, right? Because that determines if it's positive or negative. All right, so now we want to find the cosine of A plus B. Well, from the identity of the cosine of the sum of two angles, we know that this goes to the cosine of the first angle times the cosine of the second angle, and then since this is a plus, it's the opposite sign, right? And then the sine of the first angle times the sine of the second angle. And then we say, all right, well, what do we need to know? What information do we have to figure out? Well, we know what the cosine of A is, so we can plug that in. We know what the sine of B is, so we can plug that in. But we don't have the sine of A, nor do we have the cosine of B. Right, so that's where we need to do a little more work. So we go off here to the side, we're going to draw some little triangles. Right, so there's a right triangle, and let's call this angle A. Right, so if that's angle A, we note that cosine of A is 3/5. Well, cosine is adjacent over hypotenuse. Right, so that forces this side here to be 4. When you do the Pythagorean theorem, right? 25 minus 9, 16, square root of 16 is 4. Right, so now we figure out anything on A that we want, right? So let's also do the same thing with B. Okay, so you got another triangle. See, all right, this is B. And what do we know about B? We know the sine of B is 5/13. So sine of B is opposite over hypotenuse. And this is a right angle, right? So when you do the Pythagorean theorem, you get this length down here to be 12. All right? So now we can go do what we need to do. The cosine of A is 3/5. The cosine of B is what? Well, we look down here and we say, well, it's 12/13. Everybody see that? So, all right, the cosine of B is 12/13, right? Because adjacent over hypotenuse. However, B is in what quadrant? B is in quadrant 2. So what's the sine of cosine in quadrant 2? Well, it's negative, right? So this has to be a negative 12/13. Everybody with me? Very important. Okay. All right, then minus sine of A. All right, well, we know the sine of A is 4/5 because it's opposite over hypotenuse. And A is in quadrant 1. So the sine of any angle that's in quadrant 1, the sine of that would be positive. So this just stays 4/5. And then the sine of B, we already know, is 5/13. And then you add them up. So what is that? Negative 36 over 65 minus 20 over 65. So this all goes to negative 56 over 65. All right, so the cosine of angle A plus angle B, the cosine of that new angle is negative 56 over 65. Because remember, if we're taking two angles and adding them together, then we get a new angle, and we're taking the cosine of that new angle. And notice on that situation here, we don't even know what the angle A is or what angle B is. We don't need to know it in order to figure the cosine of the sum of those two angles needs to be. Follow me? All right, that's it for now. Study well. Please let me know if you have any questions.